Determine a polynomial function with degree 4 that has a 0 at x equals 4i and a 0 at x equals 3 with a multiplicity of 2, and the x squared coefficient is given to be negative 25. Write the function in factored form and expanded form using only real numbers. Let's first list the zeros and the corresponding multiplicity. Remember that complex zeros come in complex conjugate pairs, meaning if 4i is a 0, then so is negative 4i. So we have a 0 of x equals 4i that has multiplicity 1. We have another 0 of x equals negative 4i that also has multiplicity 1. And we have the 0 of x equals 3 has multiplicity 2. If we let a equal the leading coefficient, we can write the polynomial function p of x as p of x equals a times, because 4i is a 0, x minus 4i must be a factor. And because the multiplicity is 1, we only have one of these factors. Because x equals negative 4i is a 0, we must have a factor of x minus negative 4i. And we have one of these factors because the multiplicity is 1. And for the 0 of x equals 3, we have two factors of x minus 3 because the 0 has multiplicity 2. Let's go ahead and simplify and write p of x as p of x equals a times the quantity x minus 4i times the quantity x plus 4i, and then times the square of x minus 3. We only want to use real numbers, and therefore now we are going to multiply x minus 4i and x plus 4i. Let's do this on the side. I'll go ahead and show all four products, 1, 2, 3, and 4. We have x squared plus 4xi minus 4xi, and then minus 16i squared. Simplifying, 4xi minus 4xi is 0. I squared equals negative 1. We have x squared minus 16 times negative 1, which simplifies to x squared plus 16. We now know that p of x equals a times the quantity x squared plus 16 times the square of x minus 3. We still don't know the value of a. We'll have to expand this, determine the value of a, and then come back to the factored form. For the next step, let's go ahead and square x minus 3. We have two factors of x minus 3. And again, we have four products, 1, 2, 3, 4. We have x squared minus 3x, which is minus 6x, and then plus 9. So now we can write p of x as p of x equals a times the quantity x squared plus 16 times the quantity x squared minus 6x plus 9. And now we'll determine the product of the binomial and the trinomial. This will require 6 products. We distribute the x squared and then the 16. X squared times x squared is x to the 4th. And then we have minus 6x cubed plus 9x squared. And now distributing 16, we have plus 16x squared minus 96x plus 144. Combining like terms, we have x to the 4th minus 6x cubed plus 25x squared minus 96x plus 144. So in expanded form, we have p of x equals a times, again, x to the 4th minus 6x cubed plus 25x squared minus 96x plus 144. And now we need to determine the value of a. Remember, we were told that the coefficient of x squared is negative 25. Notice inside the parentheses is positive 25, which indicates a must equal negative 1. So if a equals negative 1, we now know the polynomial in factored form, using only real numbers, is negative 1 times the quantity x squared plus 16 times the square of x minus 3. And then in expanded form, we would have p of x equals negative 1 times x to the fourth minus 6x cubed plus 25x squared minus 96x plus 144. But let's go ahead and distribute the negative 1 and write p of x as p of x equals negative x to the fourth plus 6x cubed minus 25x squared plus 96x minus 144. So again, the factored form using only real numbers would be this form, and the expanded form using only real numbers would be this form. I hope you found this helpful.